Right, this is the kind of question that could cost you an A or an A star in your A-level maths if you're not careful. So pay attention and save this for later. I remember doing a question very similar to this one a couple of years back with one of my students, and I made this mistake, so don't do what I did. Exam boards love trig modelling questions. So I came up with this question myself. We've got kind of like a sea here, so this is sea level, and we're going to swim along this sea like in this kind of wave fashion like this. We start with a height here. We'll say that we started with a height of 1 meter above sea level, and we'll say that the maximum height we swim up to is 5 meters above sea level, so we swim up and then down, so something like that. And let's just say that it takes us 10 seconds to get to sea level. So starting from this 1 meter height, we're going to go up to 5 meters and then go back down to sea level. That journey takes 10 seconds. So again, that there is 10 seconds. So let's say that the model for this journey is this here. So h, the height, is equal to a sine bt plus c, where t is in seconds. And we'll just assume that this angle bt plus c is in radians. It could be degrees, depends on the question. If they do put a degree symbol in the angle, then obviously it's degrees. If not, assume it's radians. So the question is to find a, b and c. Now, finding a should not be too difficult, because if we think about a sine wave, the maximum value of a sine wave is 1 and the minimum value is -1, okay? So the maximum value of this sine wave is 5, so that a must be 5. Hopefully you are fine with that idea, but do let me know if you have any questions on that. Again, that value there has a maximum value of 1, so we need that to be 5. So the next easiest thing to do would be to find c, this plus c in the model, okay? So if we go back to the diagram, we started with an initial height of 1 meter above sea level. So when t is 0, h is 1. We can plug in t equals 0 here and h equals 1 into there. So we just sub in the variables. So we get 1 is equal to 5 sine b times 0 plus c. Sorry for my scribbled out writing there. I accidentally put 0 for the height instead of 1. It should be 1. So we get 1 is equal to 5 sine c. And so 1/5 is equal to sine c. You can do sine inverse now to work out c. Now again, our question is in radians, so we're going to use radians for this one. You should get about 0.201, but if it's in degrees, again, you have to use degrees if it was a degrees question. So far, so good. We've got this model here, 5 sine bt plus 0.201. We just got to find the b now, and this is specifically the point where we need to be quite careful. Now, this is where we're going to use this bullet point, okay? So it takes 10 seconds to get to sea level. So going from here to here takes us 10 seconds. So in other words, what that means, when t is 10, h is 0, right? When the time is 10 seconds, the height is 0. So we can just plug in those values into our model like this. And now we can divide by 5 on both sides, get something like this. Now, you may be thinking, great, we can just do sine inverse on both sides, which is fine. So we get something like this here. So you can do sine inverse of 0 on the calculator. You should end up with 0. So you would get this if you were to do that. So then by solving this, you would end up with something like this here. So the b looks like it's around minus 0.0201. So if that calculation was to be correct, this would be your final answer for the model. Now, hopefully you could tell by the tone of my voice that this final answer is not the right final answer. I mean, the 5 is fine, this there is fine. It's just that this b value that we got is not right. Now, I was going to go through why that was the wrong b value and give you the correct solution, but I am going to be a bit of a word rhyming with Nick. The first person who can comment below why that b value is wrong and give me the correct b value to 3 sig figs, you'll get a free, unreleased Edexcel past paper for your revision that you can't find online. I'll DM you one of these papers here. And if you want the rest of those unreleased papers, you've got to join my coaching program. But good luck finding the b value. I look forward to seeing your responses.